I'm going to go ahead and click the electrical design, and we're gonna string it. So first, the tool tells you define the electrical design, and it says, okay, your default system DC to AC ratio is 125%. So I can just use my slider and make it higher if I wanted to. Say, 155%. And it's going to change the inverter based on my DC to AC ratio. So 125, the tool is recommending that I use an SE10000H, and at 155, it recommends I use a 7600H. The advantage of going that high on a DC to AC ratio is now with the 7600, I fit that 40 amp breaker in most 200 amp panels, right? So I'm using probably a 200 amp panel. That means I can use a 40 amp breaker, and I'm avoiding that main panel upgrade. Now, some of you out there might be saying, oh man, that's gonna clip a lot. We're gonna see what the clipping is gonna look like in the submarine reports, but also consider this is an east-west array. So I'm already taking a 20% hit on energy production. Plus I have a lot of shading elements down here at the bottom. So that's probably gonna take a hit on energy production. So it may not actually clip a whole lot. The optimizers that are recommended for the panel that I selected are these three optimizers, the P400, the 405, and the 505. So the tool only will give you optimizers that are compatible with the solar panel that you selected, and it will also say that it will recommend the lowest power classification first, because those are typically the most cost effective. So we're going to stick with the P400, and we're going to click generate. So on my canvas I can see the 7600 dropped. The tool is telling me drag to connect modules to a string, control to add non-adjacent modules. So my string tool is already selected, and I'm going to basically just left click and drag to start stringing my modules. And as you can see, as I'm dragging, the tool is telling me, okay, you have 1, 2, 3, 4, 5, 6, 7 modules on this string. I'm gonna go 8. Okay, fantastic. Once I hit 8, that is a compliant design. And then let's make it a little bit longer. So 10, 11, 12, 13. And I'm going to say 14, 15, 16, 17, 18, 19. Oh, 19 optimizers. That's too many for this inverter and for these optimizers. So 19 says it's a non-compliant design because that's too many modules. So I'm going to cancel out this string, and we basically have like 34 solar panels. We can see we have 34 solar panels. So I'm going to try to kind of divide that by 3. And so I'm probably going to have, let's undo that. Okay, we're going to have 13, and then we're going to say 6, 7, 8, 9, 10, 11, 12, 13, and then we're going to do this on one string. Oh man, that string does not look very good. So at SolarEdge, our minimum string length is 8 optimizers for the P400. Now, what if I change this to a P405? And I can say, okay, actually, I'm going to click the optimizer button. I want to make that P405. So now I have some 405s. And what's interesting about that string, it was with the 405, I can run shorter strings. Look at that. I have 1, 2, 3, 4, 5 strings, and then, or 5 modules in a string. And the second I hit 6, it's a compliant design. So if I have these, smaller strings, I always recommend that you use a P405 or a 505. So that's what I'm going to do there. And same thing with this one. I'm just select this, and I'm going to change that to a 405 as well, because it's a short string. It's 8 optimizers. I want a better boost capability. Okay, so here's our design. We have a 7600. DC to AC ratio is 141%. We're using 3 strings.
For additional information and access to more in-depth tutorials, go to SolarEdge.com, select Login and e-Learning to get access to the library of SolarEdge learning materials.